In the same way, we can obtain this ds upon dy. This is dy upon, okay, if I write ds upon dc, ds upon, sorry, dy, okay, this is equal to ds upon dc into dc upon dy. Okay, so dc upon dy will be like this, and ds upon dc will be 1. This dc upon dy is this formula which we have to, or dc upon dy in this case, dc upon dy. Okay, from this whole formula we can obtain this. This is the second formula which we have, which is y delta by dy. Okay, in case of limiting quotient when q tends to p, this is the second formula which we have to drag here. Let me take the marker. Okay, so ds upon dx upon dy, ds upon dy, and ds upon dx. These two formulae we have obtained. Now let me take when q tends to p, what are the other things which we have to drag? So let me take other formula. In case when q tends to p, then what is cos psi? Now let me take some formula. This is origin. Okay, when, let me take, this is called axiom or corollary. Let me take axiom or corollary 1. This is corollary number 1. What is that? There are certain results which are based upon these results. Okay, this figure. So let me take when q tends to p. Okay, in that situation when q tends to p, as I have told you, this gap will not be there. This q occupying p, this angle alpha is between PR and tangent. PR and tangent. So this tangent is making an angle psi. This angle alpha will become psi angle. Okay, so in that situation, let me write here cos psi. What is the value of cos psi? Cos psi will be limit. Let me write here limit q tends to p, or delta x tends to 0. In that case, not 0, only q tends to p. Sorry, q tends to p. And that means cos alpha. This cos alpha angle is equal to, what is cos alpha in that situation? So that will be q tends to p, then delta y upon cos alpha is delta x, this based upon hypotenuse. This will be, okay, limit q tends to p is delta x upon delta c. Okay, or why? Because this is a right triangle. So in this situation, limit delta, q tends to p, this is q tends to p, when delta q, limit q tends to p, in that case delta x upon delta s, right here, into delta s upon delta c. Okay, so delta s upon delta c is 1. This is delta x upon delta x upon delta s. Okay, this will give us, okay, dx upon, in case of limiting position, dx upon ds only. Why? Because this is 1. ds upon s, since, let me write here, delta s upon delta c is equal to 1 when q tends to p. Okay, when q tends to p. When q tends to p, delta s upon delta c is equal to 1, or chord, we know that this chord P.Q, also Arc P.Q upon chord P.Q is equal to 1, that we have assumed already. This delta s upon delta c is 1. It means cos psi is equal to that delta dx upon ds. It means, let me write here, cos psi equal to dx upon ds. This we have obtained first equation. Now let me take sin psi. So then sin psi will be equal to how much? Since sin psi will be equal to, here in this case, dy upon ds. This will be dy upon ds. Okay, from this triangle dy upon ds, because delta c upon delta s or delta y upon delta s will be there. So dy upon ds. Again, similarly, we can obtain this after when q tends to p. This is delta y upon delta c, but delta c can be written as delta s upon delta c, delta s upon delta c again 1, delta y upon delta s only. That means when limited position, delta x, delta y upon delta s will be dy upon ds. So sin psi is dy upon ds. Yes, sin psi into dy upon ds. Okay, so if we square them and add, so after squaring and adding, sin square psi plus cos square psi is equal to what? This is equal to dx upon dy for ds whole square plus dy upon ds whole square, or this is 1, so 1 is equal to dx upon ds whole square plus dy upon ds whole square. Okay, so this is one of the formulas is 2, and after this, the third one, we have to find out the relationship between these dx and ds and dy and ds. This is one of the relations we have obtained. Let me take other corollary. Second corollary is all these values of this can be obtained from that formula. So now let me take when parametric form is there. The functions are given in parametric form. In that situation, okay, and these formulae dy upon ds, we know that tan psi. Okay, and these form before taking corollary, let me take these formulae can also be obtained of the sin psi and cos psi. These formulae can be obtained from, okay, from dy upon dx is tan psi. Okay, dy upon dx, we know that tan psi equal to dy upon dx in this case. So dy upon dx, because it is tan psi. So if I just take that what is cos psi or second psi. So if I write cos psi equal to, let me write here cos psi. This was nothing but dx upon ds for dx upon ds. Alright. So if I write it as secant psi, this is ds, let me write dx upon ds is equal to 1 upon, you see ds upon dx here. Dx upon ds is cos psi, or this is 1 upon secant psi. If I write here. Okay, so cos psi is 1 upon secant psi. But secant psi can be written as 1 plus tan square psi. Okay, so this is equal to 1 upon under root 1 plus dy upon dx whole square. But this is what? This we know what is under root 1 plus dy upon dx whole square. The ds upon dx. This is dx upon dx. This we know what? But this is nothing but dx upon ds. Okay, so dx upon ds, which is cos psi can also be obtained from tangent psi or something. Okay, so second psi, so cos psi is equal to this one, 1 plus tan square psi 1 upon under root. This is dx upon ds again. Dx upon ds can be obtained from tan psi, or cot psi is equal to, in this case, sorry, cot psi. So, and cot psi will be equal to dx upon dy. It's the reverse of tan psi. This is dy upon ds, this is dx upon dy, or dx upon dy. This is cot psi, this is based upon perpendicular. Cot psi is this. In this way, we can obtain dx upon dy. If I find out sin psi, let me write here what is sin psi. The value of sin psi was, if I write sin psi, this means tan psi into cos psi. Tan psi cos psi means tan means sin upon cos. Cos tan, this is sin psi. If I substitute value of tan psi in terms of dy dx or something, so this is dy dx, and cos psi is dx upon ds, dx upon ds. This is cos psi. Now ds cancel out, so this is nothing but dy upon ds. So sin psi is dy upon ds. This we know what. So dy upon ds is sin psi, which we have just proved. These are different formulae which can be obtained in any way. Okay, in either of the way. Initially we describe from the figure given, then tan psi is this value. So from tan or cot or secant or second we can find out other trigonometric ratios. Okay, here are the formulae which are based. Now let me take second axiom or corollary. So second axiom second, this is the result based upon or axiom or corollary. This is corollary second. So what is second corollary in this case? If parametric equations are given, okay, if x and y are expressed in parametric form, are expressed in parametric forms. Okay, that is, if x equal to ft, let me write, and y equal to ft, means x is given in terms of t, the parameter, and y is also given in terms of t, parameter. In that situation, what do we do? What we have to find out? What is ds upon dt then? We have to find out what is ds upon dt. That we have to find out. So ds upon dt, okay, ds upon dt can be written as ds upon dx. This is ds upon dx into dx upon dt. Okay. This is value of ds upon dt. We are writing, we are divided by dx and dx. Okay. But we know that what is ds upon dx? Ds upon dx initial, the first formula we obtained. It can be written as under root ds upon dx is 1 plus dy upon dx whole square. This we have proved in the first form, first formula. Value of ds upon dx, differentiation of s, the curve, okay, the arc, I mean, respect to x was given as under root 1 plus dy upon dx square into, this is dx upon dt. Dx upon dt, the last term we have written as it is. Now if I take this inside the square root, then it will become, it has to be whole square and square root both are same. So if it is square and square root, and under square root we can take that, so it will become as dx upon dt. If I multiply this by 1, this whole square, okay, plus this dy upon dx would also multiply this whole square into dx upon dt whole square under the square root. No change. Why? Because dx upon dt are taken inside the square root after squaring this and taking the square root of that both. Now this 1 into dx upon dt whole square, the dy upon dx into dx upon dt whole square, same thing. Here dx upon dt whole square is cancelled out. So what do we obtain? In case of parametric form, dx upon dt is equal to under root dx upon dt whole square plus this is dy upon dt whole square. Okay, so this is the formula for parametric forms. This is equal to ds upon dt. In case of parametric forms, when parameter t is given, parameter theta is given, any parameter s is given, other parameter, other variable other than x and y, and x and y are expressed in other variable, third variable. The third variable is known parameter. We know that parametric, what is the parametric equation we have described already. This is the equation, this is the formula. I mean, there is a fourth one, I think I have derived here, this formula. And before that, 1 is equal to, okay, that formula was there. So 1 upon dx upon ds whole square, dy upon ds whole square, that was also there in case of sin psi square, cos psi square. That was third question. This is the fourth one we have taken. So all these four formulae we have derived from for Cartesian formulas. Cartesian formulas, which are very important, we have to solve questions with the help of this that will be discussed there. Now, let me take what are the polar, okay, polar formula, or in case of polar coordinates, the polar formula. In place of Cartesian now, let me take polar formula. So, describe polar formula. Polar formula. Now let me describe. Okay, let me try what is the polar formula. that I have to describe it. In case of Porter formula, as I have already told you, okay, yes, express that. We have to find out what is ds upon d theta, ds upon dr. So that is derivative of the arc with respect to theta or with respect to r. Okay, so r and theta. These are two variables in case of polar coordinates. Okay, so let me take a figure which is in case of radius vector and a curve given. The similar type of curve which we have to describe. Let me take here. Okay, so this is the chord PQ. Okay. And here chord PQ. Let me take here P, this is Q point, and if I join this pole to, let me write here. Okay, so this is pole O, this is pole O. Okay, from this O, I have to draw radius vector. Okay, a radius vector to P, this radius vector, making angle theta with the axis, with the original axis, or with the initial line. This is initial line known as OX is initial line. So this theta angle, and this is delta theta. Okay, angle made by QR. And let me take coordinates of P as R and theta, and this is R distance up to this point P. R is OP is R length, and this is R plus delta R. I have taken coordinates R plus delta R and theta plus delta theta of Q, and P is R and theta. Now if I draw a tangent line upon this point, let me take the curve like this. Okay, if I draw a tangent line upon this point, and this is the chord PQ. So this OP radius vector is extended further. Let me extend this further. Okay, this P is going towards this point. This is T tangent. Okay, not try to let me further draw. Okay, this is the tangent line, and this is the tangent. Okay, is okay. Okay, so this point P here, and this is the arc. This is A point I have taken here. Length AP again S, and this is delta S here. This length, this is delta C. I have taken again. Length of the arc PQ is delta S, and length of the chord PQ. This chord PQ is okay S. Sorry, delta C. Delta C is the length of chord PQ. Now the angle here, let me take this angle phi, or the angle between tangent and the radius vector R is phi we know. And again this angle, if I draw perpendicular from P to this, okay, this is the radius vector, and upon the radius vector I have drawn a perpendicular. This is radius vector. So okay, let me take this. This is as OPQ I have taken. So let me take R point, and this is T dash point of T I have taken here, tangent, and this is T dash. T dash that not required. Only this one is required. So this angle alpha. Let me take angle alpha is this one. This alpha angle we used to take. Now this angle alpha, okay, when become phi, this phi angle, that we will discuss later when Q tends to P. In that situation, angle alpha, because this Q is taken as along the tangent line, this is the tangent line. Okay, some mistake is looking, but let me clarify this. Okay, this is your radius vector. Okay, this is your tangent line, and this is the curve here. Okay, and this is the chord. This is the chord. Let me take this as chord. Okay, this is the chord here. With the chord, this PQ is the chord. Sorry, PQ is the chord. Without scale, it's very difficult to. No problem. Now this is your arc, and this is the chord. Let me take here. This is delta S. Okay, now let me take further things. Now let me describe this. This is the arc. Okay, so obvious. Now this is clear. Again, I'll try this, no problem. So drawing this is not easier, or I mean not a difficult one that I can do number of times. So let me take what is the point we are going to discuss. Okay, we have to find out ds upon d theta, ds upon dr. For that, first of all, we have to talk about in this right triangle. Which one? In this right triangle, PQR, because this is right triangle. In that situation, what is QR? What is PR? If I take this and no problem, this is PR here. So what is PR? PR length is, because this is total is OR minus OP. Okay, so this total is R per delta R. This length is delta R here. I'm sorry, this is delta R, but this length is R here, R minus sorry, this OP minus OP is the length PR. So PR equal to, let me write here, PR equal to OR, this is OR minus PR. Sorry, PR equal to OR minus OP. Okay, so this OR minus OP, what is OR here? Now if I find out OR in this whole figure, okay, in situation when this Q tends to P, then this figure will become, this right triangle will become here, sorry, this triangle will become as a complete triangle from ORQ will become a right triangle. In that situation, we will take the right triangle. So this OR is this, sorry, this OR we are taking OR. OR is what? R plus R into cos alpha or cos delta. This is cos delta theta in that situation. And this is R. So this PR is equal to, this PR we have taken here. This we have to use here. R per delta into cos delta theta minus R. This is value of PR. Let what QR? Where QR is R plus delta R into sine delta theta. Why? Okay, in triangle ORQ, this is angle opposite to this. Let me take angle alpha. This is perpendicular. So perpendicular upon hypotenuse. This is hypotenuse. This is perpendicular. Okay, angle opposite to delta theta. For delta theta angle we are taking here. Delta theta angle, that means ORQ is the right triangle. So in ORQ right triangle, QR upon OQ, QR upon OQ, OQ is R per delta R. This R per delta R, radius vector for Q. Okay, so that is based upon angle theta per delta theta. But this is delta theta only in this right triangle OQR. We have taken, okay, this length R per delta R, and this OP upon this is perpendicular upon hypotenuse, that means sine phi, sine delta theta. Sorry, this is sine delta theta here. then sine delta theta into r plus delta r equal to QR. Okay, I mean QR, let me write here QR divided by OQ equal to sine delta theta. But OQ is r plus delta, OQ we see here r plus delta r. O, so QR is equal to, this is QR equal to OQ into sine delta theta. OQ is r plus delta r. This we have to use, I just discussed here, this sine delta theta. Similarly, this length PR, what is PR? PR we have to find out. PR means OR minus OT. OR is the same line. I have taken some different one, and this figure will come here. Okay, OR is not looking a straight line. I'm sorry to say, this is straight. It can be made as a straight line. Made as a straight line. Okay, this is phi angle. So this is the straight line here. OR is the straight line. OR minus OP. OP is R in this vector. So this value is PR. PR is R plus delta R. R plus this is delta R. R plus delta R into cos delta theta minus R. Okay, so now let me take what is the value of delta C in the right triangle. This what is delta C here? Now let me describe this whole figure. Let P R theta and Q R plus delta R theta plus delta theta be the 2 points. There is the 2 points on the given curve. On the given curve, we have taken 2 points, P R theta and Q R plus delta R plus and theta plus delta theta. These 2 points on the given curve. Okay. Then AP and PQ is the, then PQ the chord, PQ the chord and arc and arc PQ. PQ is also arc and chord as well. So okay, then these two are things. Okay, let length of the arc, let length of the arc AP is S. AP is S, measured from, again the same thing, measured from a fixed point, from a fixed point A, from a fixed point A. Okay, and AQ therefore is equal to S per delta S. AQ we have taken this AQ total curve, total I mean arc, S plus delta S, because this AP is S and PQ is delta S. So this implies that PQ is equal to delta S. This is arc PQ. Arc PQ equal to delta S. And further let chord PQ is equal to delta C, length of the chord PQ. This is length of chord PQ. Length of chord PQ. The length of chord PQ we have taken as delta C. We have just taken this. Now we have dropped a perpendicular QR upon OR or upon PR, we may say. Okay, so let me say that also. So this we have to take, which I have already described, that how we have to take this figure, okay, and different things from this figure. So that is there. This is A I have taken here. This is R per delta R, this length. So what we have taken, this is important information. Now let me take delta C here. So the QR is perpendicular. QR is perpendicular upon PR or upon OR. Let me take OR. OR is the straight line, looking some curvilinear, but I'm sorry, OR or PR upon PR or OR, OR is the bending line, okay, 1 perpendicular. Therefore, in right triangle PQR, PQR let me take PQR, we have chord PQ, again chord PQ, chord PQ whole square. Chord PQ is the hypotenuse, so chord PQ whole square is equal to PR square plus QR square, right triangle. So here PQ is delta C. PQ chord, length of the chord PQ is delta C. Delta C square is equal to, what is PR square? PR I have already given here. This is R per delta R per this one. First let me write sign one. This is QR. So what is QR here? QR is R per delta sine delta theta, that I have written here. This is R per delta R into sine delta theta, very important, whole square. This is QR value plus PR square. That means this is R per delta R into cos delta theta, okay, minus R. Don't forget this. This is a whole square. So whole square of this value plus this square, PR square plus QR square, QR square plus PR square equal to PQ square, this right triangle. This I have written here, let me write in detail. So this is delta C, let me take, then it will become whole square root of delta C equal to square root of this, which is R per delta R into sine delta theta whole square. This is sine square delta theta R per delta R whole square, because the whole square of this is multiplication R per delta R whole square into sine delta 1 square delta theta, minus, sorry, plus sine. This is R per delta R per delta R into cos delta theta minus R. If I subtract this R, okay, this is R per delta R to cos delta theta, okay, this is whole square, okay. So if I describe cos delta theta in series form, that means 1 plus delta theta whole square upon factorial 2 and so on, okay. I mean 1 minus delta theta whole square upon factorial 2, delta 4 upon factorial 4, etc. And sine delta theta is delta theta minus delta q upon delta theta whole cube upon factorial 3 and so on. So I'll take, in case of the